Continuing my videos about solving with logs, I wanted to introduce the idea of the natural log. Now, the natural log is the inverse operation of the exponential function e to the x. E is considered the exponential function. It's named after Leonard Euler. That's the name e. And it is a limit that has to do with compound growth done continuously, or growth compounded continuously. So if you think about the problems you may have seen in algebra that deal with, you put your money in a bank and you get your interest every quarter or every week or every day or every hour. The bigger or the smaller that increment that you get your interest, which is unrealistic in a bank, obviously, but the smaller that increment, the closer that growth model gets to being e. So this is why it's something that got its own name and its own letter. It's approximately 2.718. It's kind of like pi in that it goes on forever. There's no fraction that you can write to represent it. And again, it's just so common that we give it its own log. So if you were to say, e to the x is equal to 50 or something like that, of course, the way we've been solving is we say, okay, log base e of 50 equals x. But most often, this idea of a log base e, we consider this the natural log. So instead, we write it this way. We do the natural log of e to the x, and we do that to the other side as well. Natural log of 50. Of course, whatever you do to one side, you do to the other. And when you take the log of an exponential, it takes the exponent and drops it out front like a multiplier. So we've got x times the natural log of e equals the natural log of 50. Well, the natural log of e is just 1. So it's just x equals the natural log of 50. And we can type that into our calculator. So we just literally type in natural log, which is just above the or below the old log key of 50. And that's it, 3.912. Okay, so let's do another one. Okay, I've added a little more complexity here, and as we've talked about in earlier videos, you really want to save dealing with your exponential part until the end. So I'm going to begin by subtracting 2 from both sides. And then dividing both sides by 4. Now we want to get rid of the e part of this. And again, normally we do a log base whatever, but in this case we can simply do the natural log of both sides. I should have left myself a little more room. Do this. And that takes my 3x and drops it out. The natural log of e is 1, so I'm left with 3x equals the natural log of 16. Divide both sides by 3. So we've got x equals the natural log of 16 over 3. Let's type this in. All right, so we're going to write the natural log of 16, and you really want to then get out of those parentheses because it was the whole thing divided by 3. There it is, 0.924. All right, let's do one more example. Okay, I have 3 times e to the x over 2 plus 4 equals 34. Again, let's just save the exponential part till the end. We'll begin by subtracting 4. We'll divide both sides by 3. Now, I want to get rid of e, and the way to do that is natural log. So natural log of both sides. Again, takes my x over 2, plops it out front as a multiplier. The natural log of e is just 1. And I want to get x equals, so I will multiply both sides by 2. Now, again, we got to be careful here of our notation. It's the natural log of 10 and then times 2. Let's type that in. So we have the natural log of 10 and then multiplied by 2. So we got to get out of those parentheses in order to get this correct. If this video helped you, please like and subscribe for more math help.